Hi viewers, in this video we are going to see about left recursion and left factoring in compiler design. So first see what is left recursion. A grammar is left recursive if it has a non-terminal a such that there is a derivation a derives a alpha for some string alpha. Top-down parsing methods cannot handle left recursive grammars, so a transformation is needed to eliminate the left recursion. The left recursion will be in the form of production, pair of productions, A derives A alpha or beta. So here we are in need to eliminate the left recursion. Why? Because the top-down parsing methods cannot handle left recursive grammars. So we need to eliminate the left recursion for the given input production. So to eliminate this left recursion, we need to introduce a new non-terminal or variable called a dash. Then the grammar or the production will be rewritten as a derives beta a dash and a dash derives a alpha a dash or epsilon. And let's see one simple example to identify and eliminate the left recursion in the given input grammar. So here grammar is given. The grammar consists of three productions. The first production is E derives E plus T or T. And next production T derives T star F or F. And third production F derives within the bracket E or ID. So let's see the first production E derives E plus T or T. We are checking whether it will be in the form of left recursive pair of productions or not. So the given production is E derives E plus T or T. So it is A. The E will be in the form of in place of A. And next this E is in the place of A, and the alpha will be a string that is called plus and T, and next the beta will be in place of T. So this production exactly will be in the form of left recursion, that is A derives A alpha or beta. Simply we can say is that if the left hand side of terminal and right hand side of first terminal will be the same, we can conclude that it is left recursion. Then we need to avoid the left recursion. So finally the input production, the first production will be in the form of left recursion. So we need to eliminate the left recursion. How we need to eliminate the left recursion? So we need to rewrite the production will be in the form of a derives beta a dash and a dash derives alpha a dash or epsilon. So here we are eliminating the left recursion for the first production, that is E derives E plus T or T. So here uh, the first form will be A derives beta A dash. So here A is E. So E derives here the in place of beta we have here T. So T in place of A dash we have E dash. So E dash. And next E dash derives plus T, which means that alpha. Here alpha is plus T. It is will be alpha. So alpha is plus T and next A dash or epsilon. So after eliminate the left recursion of the production, we got two production, that is E tends to T E dash and E dash tends to T E dash or epsilon. And next production is T derives T star F or F. So here the left hand side of this first T and right hand side of this first T will be same. So we can conclude it is left recursion. We need to remove the left recursions. Also it will be in the form of alpha, A derives A alpha. Alpha is star F or beta. So we need to eliminate the left recursion, and the new form of the this production is T derives F T star and T dash derives star F T or epsilon. And next the third production F derives bracket E or ID. So here in the left hand side we have F and in the right hand side we have open brace, that is terminal. So this is not comes under left recursion. And next for the given input grammar is E derives E plus T or T, and T derives T star F or F derives bracket E or ID. So after eliminate the left recursion, we got this grammar, that is E derives T E dash, E dash derives plus T E dash or epsilon, T derives F T dash, T dash derives star F T dash or epsilon, and F derives bracket E or ID. And next another example is given here. Consider S derives A, capital A, small a or B, and capital A again derives A, small c or S, D or epsilon. So in this case, the non-terminal S is left recursive because, so actually while seeing here in the left hand side we have S and right hand side we have capital A. It is not actually while seeing, it is not left recursion. But if you substitute over capital A as capital SD again, so now it will be S and S, it will be same. So it's not immediate left recursive. If we substitute over A, we will get the left recursion. Next one is left factoring. Left factoring is a grammar transformation that is useful for producing a grammar suitable for predictive or top-down parsing. When the choice between two alternative productions is not a clear, we may be able to rewrite the productions to defer the decision until enough of the input has been seen that we can make their choice. For example, if you consider statement derives if expression then statement else statement, and again a statement derives if expression then statement. So in this case, if expression then statement up to this prefix will be same for the two productions. Here only else and statement will be something different. So we can write this production will be in the form of A. A means statement, and alpha, beta 1, alpha, beta 2, which means that the common terms will refer as alpha. The rest of the things we will refer it as beta 1 and beta 2. For example, over here, if expression then statement will be alpha, the else statement will be beta 1. So here, if expression then statement will be a alpha, so after follows this production, nothing is there. So we can consider it as an epsilon. So that may be a beta 2. So we can write in the general form of A derives alpha beta 1 or alpha beta 2. If we have left factoring over for the given expression A, there is alpha beta 1 or alpha beta 2. In this case, the common factor is alpha alpha for these two productions, and beta 1 beta 2 is not same. So after left factoring, the grammar will be rewritten as A derives alpha A dash, the A dash derives beta 1 or beta 2. So similarly, we will apply the left factoring on the following grammar. The following grammar consists of two production. The first production is S derives I capital E T capital S, or I capital E T capital S E capital S or A, and E derives B. So in this first production, we have common terms called I E T S here, and here I E T S. So these two are common factors. So we are applying left factoring on the first production. So here IETS, IETS are common factors. So what we have replaced over here is the common prefixes with S dash, because this production is derived from S derives IETS, IETS, ES or E. So here the common prefixes we are writing with S dash, that is S derives IETS, and the following symbols we have written as S dash or A. So again, S dash derives ES or epsilon, because if we have substituted in place of S dash ES, we will get this one. In case if we over substitute epsilon in S dash, we will get this first one. So finally, the after left factoring, we got the grammar as S derives IETS S dash or A, and S dash will be E capital S or epsilon, and E derives B. Thank you all for watching this lectures. Thank you.